Our project is based on growing your organs with the help of bioprinting.
Bioprinting is the artificial construction of living tissue through the outputting of layer upon layer of living cells. It's a process where biomaterials such as cells and growth factors are combined to create tissue-like structures that imitate natural tissues.
How does this technology work exactly? There are approximately 5 steps to bioprinting. First, you have to get the 3D imaging done. To get the exact dimensions of the tissue, a standard CT or MRI scan is used. 3D imaging should provide a perfect fit of the tissue with little or no adjustment required on the part of the surgeon. Bioink is a combination of living cells and a compatible base, like collagen, gelatin, silk, or alginate. The latter provides cells to grow on and nutriment to live on.
The first version of this manufacturing technology was introduced in the 1970s with the work of Japanese researcher Dr. Kodama. He invented a layer printing technique using ultraviolet light to cure photosensitive polymers. On July 16, 1984, American Chuck Hull filed his patent, a patent for the process of stereolithography. Although this type of technology might sound amazing, it still has its pros and cons. Bioprinting reduces the chances of organ trafficking. It decreases animal testing, waiting time for organ donors, and it's more precise than traditional methods of building organs by hand. The cons are liability if a printed object fails, consumption of large amounts of energy, difficulty in maintaining cell environment, and pricing.
Who could this type of technology help today? 3D bioprinting is really opening new perspectives and offering new interesting possibilities to the medical industry. The researchers will allow getting cells living and growing in their environment, reacting the same way that cells inside of a patient's body. This method also appears to be a good solution to study cancer growth and see the reactions of the cells. Their main targets are ill patients who are seeking for medical attention but are not willing to stay on the wait list. Growing your own organs could reduce the death rate of willing donors, and the ones who are waiting for a transplant have the other risk of not making it to the top of the list, thus passing away.
Bioprinting is a legal process that is still under research. Although they are close to creating organs that actually will last, researchers have said that they'll finally be able to rely on these prototypes in 15 years to 20 years. We support this technology and we think that it should be supported in Canada. If we use this opportunity wisely, we can expand our technology growth and potentially create an outbreak and help those in need. Although the list for organ donation is endless, we can try our best to expand our economy and change lives for so many people who are in desperate need of these donations.
This review deals with the ethical and moral issues generated by the current advances in organ transplantation, the problem with organ supply versus organ demand, and the appropriate allocation of available organs. It is emphasized that clinical organ and tissue transplantation can be more beneficial and life-saving if everyone is involved in the process, including physicians and medical institutions, respect and consider the best interests of the patients, as well as honor the ethical, moral, and religious values of the society.